So I had someone asking me about a weird probability question where we have eight coins that are flipped here. And so you have basically eight coins are tossed all at once and they land either heads or tails. And what we um, basically have are a couple of situations. If there are an odd number of heads, then you win. Okay, so if we'll do a little bullet point. If odd heads, then you win. Bullet point number two. If all of them are heads or all of them are tails, so if they're all the same, then it's two wins. If all H or all T, then it's a double win. And it's a loss otherwise. Okay, so what I think of here is that we can make a little table. So we have x and then the probability that you reach that x. So you win 0 times for the otherwise. You win 1 time for the probability of an odd, and you win twice for the probability that all H or all T. So let's think about that. So the probability that they're all going to be heads is a binomial distribution. So the probability of all heads is going to be, we're choosing all eight of them to land there like this. And the probability that they're all tails is going to equal the same darn thing. So the probability that x is going to equal 2, that you're going to have two wins, is 2 times, well, 8 choose 8 is just 1. Zero point 0.5 to the 8 is only the really relevant part. 0.5 to the 0 is 1. So this is really just 0.5 to the 7. So 0.5 raised to the 7. So you're going to get two wins with a 0.0078125. Okay, so then let's think about the probability that there's an odd number of heads. I think we have to just break this into cases. I don't think there's a way to do it all in one step. So what we can do is find the probability of 1 plus 3 plus 5 plus 7, and they're going to look very similar. So let's add them up. So here's the probability of getting one head. 8 choose 1, zero point 0.5 to the 1, 0.5 to the 7. And then we're going to, let me move my face out of the way. We're going to add to that 8 choose 3, zero point 0.5 to the 3, 0.5 to the 5. So 3 has 5 tails. 8 choose 5, zero point 0.5 to the 5, 0.5 to the 3, and 8 choose 7, zero point 0.5 to the 7, zero point 0.5 to the 1. Because of the symmetry of this, these two things are equal, and these two things are equal. So altogether, our probability is just going to be 2 times the one head version, because that matches with the 7 heads, and 2 times the 3 head version. So, okay, let's just write it out here. So 8 choose 1, and then it's just going to be 0.5 raised to the 8 times 2 plus 8 choose 3, oops, 0.5 to the 8 times 2. So I just simplified the 0.5 to the 8 is always there. It's 8 choose 1, 8 choose 3. So I guess I probably could have simplified that a little bit more. And you get 0.5. Interesting. Why is it 0.5? I guess half the time you'll have an odd number of heads, and half the time you'll have an even number of heads. It's kind of elegant. Okay, so we know now that the probability here is 0.5. We know here the probability is 0.007812, and the probability that you get 0 is the rest of it. We don't really care about it because the original question asked us what's the expected number of wins and losses. So the expected number of wins, remember your expected value, means you just take x times the probability of x. So one win with a 0.5 probability plus 2 wins times a 0.007812 probability means that's the expected number of wins. 0.5 0.515625. So really the most important thing though is not the answer I got, it's just how we kind of approach the problem by breaking it down into different categories and finding the probability of each of those cases separately. So, let me know if that's confusing. Thanks for watching.